Shweta here. Let's get to know about acoustics.
Hello everyone, in this video we are going to discuss about acoustics, which is in unit 5 of standard 10. Acoustics not only deals with the musical instruments and design of concert halls and auditoria, it is a branch of physics which deals with the production, transmission, reception, control and effects of sound waves. Before moving into acoustics, we shall see the basic properties of sound. Sound plays a major role in our day-to-day life. Whatever we hear, everything around, the sound of human, animals, a guitar.
The sound from mobile phones, utensils, flow of water, etc.
So, it is very inevitable to know how it is produced, how it is propagated, how it is being received. Everything should be known. So, I am sure you will get answers for all these questions in this video. Now, we shall see how sound is produced. Sound is produced through vibrations. Let me show you one example. So I have taken a small piece of paper and I have folded it into two, and further I have folded it into one more, and then I have made a hole here. Okay, you can just pierce it with your hand and then fold it outward in a form of zigzag so that it comes like this. Okay, now I am showing you an example for sound produced through vibrations. Okay, so you'll get it like this, right? Now if you blow air in through this part, see you get sound, right? This sound is produced by means of vibrations of the small fibers, of the small piercing area is there, no? Because of that vibration, sound is produced here. This is a very short example that sound is produced through vibrations. And one more thing, so you would have remembered this, no? Another side, you would have tied a cup, and we used to make calls in our small age, right, during our childhood days. Now I have taken an use and throw cup and I have tied a small thread, and inside there is a small stick inside. I have, see, I am now pulling. Can you hear the sound? So this pierced area that I have made acts as a vibrating medium, and due to this vibration, sound is produced. Okay, so sound requires a medium to travel. Either it may be an air medium, liquid medium or solid medium, and sound waves travels faster in solids and then in liquids and then in gas. Now for example, if you and your friend are standing on a moon and talking to each other, can you hear anything? No, you cannot hear nothing. You cannot hear anything because there is a vacuum. So sound waves need some medium to propagate.
In this picture, we see that the vibrating object causes disturbances in the air molecules. This is similar in playing guitar and drum.
Sound waves are longitudinal in nature that can propagate through any medium like air, liquid and solid. So sound travels fastest in solid and then in liquid and then in gas. So it depends upon the properties of the medium where it travels. So this creates a pressure, high and low pressure, which are compressions and rarefactions. So the compressions and rarefaction together forms the longitudinal waves.
Hence, the sound waves are longitudinal in nature.
So on the frequencies, sound waves are categorized into three types: audible waves, infrasonic waves and ultrasonic waves. Audible waves, the frequency ranges between 20 Hz and 20 Hz to 20,000 Hz. So these type of frequencies are produced by vocal cords and stretched strings of a guitar. So these are the vibrating bodies. Infrasonic waves, human cannot hear these kind of waves because they are audible, because their frequency is less than 20 Hz. So these sounds are produced during the earthquake and ocean waves. All these kind of waves produce infrasonic waves. And next is the ultrasonic waves. Ultrasonic waves, the frequency range is greater than 20 hertz. These sounds are produced by bats. So human ear cannot hear these kind of sound waves. So based on the frequencies, it's categorized into three types.
Now let us see one of the applications of ultrasonic waves, which are sound navigation and ranging. In this, the sound waves are sent into the sea. It touches the seabed and reflects back. The distance between the transmitter and receiver is detected, and hence the depth of the sea is calculated. It is not only used to find the depth of the sea but also used to find the sea animals or sea objects such as sea animals and icebergs which are present underground. Thus, it is useful. Let us now see the difference between sound waves and light waves.
Sound waves are longitudinal in nature that can propagate through any medium like air, liquid, and solid. So, sound waves are longitudinal in nature, but light waves are transverse in nature. So, medium is required for sound waves propagation, but in case of light waves, medium is not required. The wavelength of the sound waves ranges from 1.65 centimeter to 1.65 meter, but the wavelength of the light waves ranges from 4 into 10 power minus 7 meter to 7 into 10 power minus 7 meter. And the velocity of sound waves is 340 meter per second, and the velocity of light is 3 into 10 power 8 meter per second. See about the velocity of sound waves. So while talking about velocity of sound waves, it is categorized into two types, which are particle velocity and wave velocity. Particle velocity, in this, the velocity with which the particles of the medium vibrate in order to transfer the energy is known as the particle velocity. For example, in a table, if you are just sprinkling some sand, and if you are one side, if you are tapping the table, what happens? The sand moves up and down, right? It comes as a wave. So the vibrations is transferred through the medium, and this is called as particle velocity. And the wave velocity, that is the velocity with which the wave travels through the medium, is known as wave velocity. Usually we know that velocity is nothing but the distance by time taken, right? So the distance taken by the wave, so we consider as the wavelength, the one full wave, right? So the crust and the trough makes one full wave, and the length of the full wave is known as wavelength. So the distance here we take it as a lambda, and divided by the time taken t. So the velocity v is equal to lambda by t. So we know that the frequency is nothing but 1 by t, right? N is equal to 1 by t. So number of times per second or number of cycles per second, whatever it is. In this, the frequency is taken as n is equal to 1 by t. And if you are substituting, we get the velocity to be v is equal to n lambda. Hence, this is the velocity of the sound waves, and the velocity is greater for solids, and then it is for liquid, and then it is for gases.
This is the overall representation of what we saw in sound waves. Sound waves are produced by vibrations. We shall see in this production, nature, classification, and velocity of sound waves. Sound waves productions. Sound waves is produced by vibrations. Example, vibrations of tuning fork, vibrations of a string in a guitar, to and fro vibrations, etc. It is also caused by the vibrations of the air molecules. These vibrations causes disturbances in the air molecules. Its nature. The nature of sound waves is longitudinal in nature, whereas in case of the light waves it is transverse in nature. Longitudinal wave nature consists of Two types, compressions and rarefactions in the wave. So longitudinal waves consist of compressions and rarefactions in the waves. Compressions are caused due to high pressure and rarefactions are caused due to low pressure. Next we shall see about the classification. Sound waves are classified into three types: audible waves, infrasonic waves and ultrasonic waves. Audible waves can be produced by human beings. It can be generated by vocal cords and vibrating bodies. And the audible waves ranges from 20 Hz to 20,000 Hz. Infrasonic waves. Infrasonic waves, the frequency ranges between below 20 Hz. These infrasonic waves are produced during earthquakes, ocean waves, etc. Ultrasonic waves. Ultrasonic waves are produced by bats. Human beings cannot detect ultrasonic waves, but by use of these ultrasonic radiations and waves, sonar which is used to detect the underwater objects, and its frequency is greater than 20 Hz. Human beings cannot detect the frequency and human being cannot hear frequencies below 20 Hz. So these are the classification of the sound waves based on their frequencies. Velocity. Velocity is further classified into particle velocity and wave velocity. So the vibrations, the energies are transferred from one particle to another. It is known as particle velocity. And wave velocity is given by V is equal to n lambda. So this equation is formed by using velocity is equal to displacement by time taken. That is the time taken for one wave. The crust and trough together is called as an wavelength. Is one wave and the length of the wave is called as wavelength. So thereby V is equal to n lambda. So this is the velocity, and the velocity of sound waves differ. They are faster in solids and then in liquids, and they are least in gases.
In this video we have seen about the introductory part of sound waves, its classification based on its frequencies, its nature and velocity, and the difference between the light and the sound waves. I think you would have understood well, and there is an activity given in your book, and all of you please try that activity, and I have attached a small quiz questions in this video itself, so everyone please try it. Thank you.
Try to answer these questions, students.